Okay, we talked about numerical models. We also talked about algebraic models. And now we're going to talk about graphical models. And graphical models are just pictures. We're going to graph and see if we can find any equations out of this. So what we want to do is interpret and use graphs. So here we have Galileo. He spent a lot of time rolling balls down inclined planes, and he recorded the distance they traveled as time went by. His experiments are commonly repeated in physics classes today, so what we're going to do is reproduce this data, and we want to know what model fits this best. So what I want you to do is we're going to put this in list 1, this in list 2, and we're going to do a scatter plot and see what the data, the points look like. So you're going to take your calculator, you're going to turn it on, you're going to go to Stat. Let's see if you can see it better over here. I'm going to look and see if I have anything in there, and I do. So what I want to do is clear the data. So I'll go Stat for list 1, comma, list 2. Now my data is cleared, and I go to my list, and I want to put in 0 through 8 into list 1. 0, 1, 2, 3, 4, 5, 6, 7, 8. And then in list 2, I'm going to put these distances. So what I'm going to do is I'm going to put in 0, 0.75, 3, 6.75, 12, 18.75, 27, 36.75, and 48. Always double check to make sure you put in the data correctly. Second, stat plot. I need to turn on my graph, so I have it on. It's on scatter plot, list 1 and list 2, and these are the points I'm going to use. You could use plus signs or you could use dots. And because I want to make sure my window's okay, I'm going to do zoom number 9, which happens to be zoom stat. So you'll hear me often say zoom stat. Now there is my graph. Now you'll notice it looks like another line came down here. So I'll go to y equals and get rid of this data. Now there's my graph. Now I don't know about you, but it's definitely not linear. It looks like it could be part of a quadratic, like a parabola. It might be exponential, but I don't think so because it's at 0, 0. So looking at this, what graph fits the data? I am thinking that it might be a quadratic. So what we're going to do is we're going to do a regression and see what we get. So hit Stat, and we're going to do Calculate. And I am going to go down to, notice this says linear regression, and then number 5 says quadratic regression. I'm going to see if it is a quadratic regression. So I hit Enter. List 1, comma, list 2. And I'm going to hit comma, vars, y-vars, function, y1. So whatever graph equation I get, it's going to put it into y1. And I'm going to hit Enter. Now I hit Enter again. Now it gave me the quadratic. Notice ax squared plus bx plus c. So it looks like it will fit 0.75x squared. That's a quadratic. Notice my r squared equals 1. That tells me it's a pretty good fit. So what you're going to have to do, if yours doesn't show up like that, what I want you to do is second, catalog, and you want to go alpha D, and you want to go to diagnostics on, and then you're going to hit stat, calculate, number 5, which is the quadratic regression, L1, comma, L2, vars, y-vars, function, and then y1. Now if I go up to here, you'll notice the graph was automatically put in, or the equation was. So now I hit graph. Voila. It's a pretty good fit. Now I'm going to step through this diagnostics with you. If I have to, and your R doesn't show up, what you want to do is you push the second button, and then catalog is the 0. And notice you've got a bunch of commands. If you press the alpha button and go to letter D, it will scroll alpha D. It'll scroll to those commands that start with D. I'm going to scroll down until I see diagnostics on, hit enter again, and that allows these R values to show up. Sometimes when you power down, it'll go away, and that's all you have to do is get the diagnostics back on. All right, they want the percentage of females in the U.S. This gives me just the number of females. So this is what we're going to do. In list 1, we're going to put the years starting at 1980 represents 0, while 2000 is going to represent 20. Okay, so we're going to put in list 1 the years. So let's see. Go to Stat, Edit, 0, 5, 10, 20. Okay, now we need the percentage. So what we're going to do here is we're going to put in 12 divided by 316 times 100. That will give us the percent. 21 divided by 480 times 100. That will give us the percent again. 41 divided by 740 times 100. 64 divided by 1085 times 100. 92 divided by 1382 times 100. So now we have all the percentages in list 2. Now we're going to go second, stat plot, turn it on. It's on, scatter plot, list 1, list 2, everything's wonderful. Now we do zoom 9. We're going to look at that. Does that look linear? It kind of does. Not completely, but kind of. So let's see how well it looks. I've got a weird line there, so I'm going to take and get rid of that. And now I'm going to do stat, calculate. I want to do a linear regression. List 1, comma, list 2, comma, vars, yvars, function, y1, enter. And I want to see that my linear regression gives me y equals 0.1148. 1448 x plus 3.805. So that's what we're looking at. The r is 0.989, but the r squared is 0.9786. The closer we get to 1, the better that it is. So now I'm looking at this and I'm going to say, okay, that's not too bad. Let's see if we can get a quadratic regression and see what it looks like. So stat, calc, I'm going to go down to number 5, quadratic regression, list 1, comma, list 2, comma, vars, yvars, function. I'm not going to put it in y1 because that's where the linear is. So I'm going to put it in y2, and I'm going to hit enter. So now with the quadratic regression, I have y equals negative 0.00127 x squared plus 0.170x plus 3.742. This time my r squared is 981. Let's compare these. It looks like the linear is not as good of a fit as a quadratic. Well, let's see what it looks like. There's my linear. And I don't know if you can see it, but on top is the quadratic. And I think it's a parabola that goes downward like this. It's very hard to see, so let's see if I can put it in either, I think a floating O would be better. So let's see what this looks like. There's my linear. There is my quadratic. Can you see the floating O? It almost is following the linear. They're very close, very similar. So now we'd have to decide which one we want to use. Without enough data, it could be either or. Now this is what we filled in list 2. It was the percentage of female population. So we take the female population divided by the total population times 100, and that's what we put in list 2. You were saying, man, she went too fast through that, so I wrote it down. Here's how we get an algebraic model from a graphical model. You create a scatter plot, so you put the data, stat, edit, enter data into list 1, list 2 is needed. You go to your stat plot, you turn it on, you change your window as needed. Usually zoom stat will put it correctly. You calculate the regression that you think is going to best fit it. Stat, calculate. You could choose linear, quadratic, cubic, etc. List 1, list 2, vars, y-vars, function. y1 is when you put it in the first equation. You could put it in y2 through y10. And you hit enter. You make sure your diagnostics is on so that r or r squared is close to 1. In step 2a, you put the regression function into y1 and then it is superimposed onto your scatter plot. And that will check to see how accurate it is, just like we did here. If you notice, when I go up here, both equations were put in and there's no rounding errors. They put in exactly what the calculator calculated.